Good evening, everybody. We're just going to maybe get started once Brent stops talking. Thanks, everybody, for coming out to what is, I guess, the third event. We've started kind of an interesting sequence of a TT person presented at Gensler, and now we're at TT, and we're presenting the work of John Tolva from PEP, Positive Energy Practice. This evening, I think everybody did a really good job of the RSVP thing, worked out really well, so I think that we're going to stick with that, and hopefully we'll make announcements for the next events, hopefully a little bit earlier. This kind of came together pretty quickly, which is great. I think
now we're going to spam your email.
Right, exactly. Now we have plenty of spam to come. I think what would be good is if you guys have ideas for presentations, or if you think that there is somebody that would be a good person to talk or be part of kind of a larger discussion, please let us know. And you could use info@chicagocomputation.com, or you can submit it right on the site. We're also starting to post the videos of the presentation, so we have 2. I think shortly we'll have 3 up there. So take a look at those. Hopefully they get kind of forwarded around, and this is a great turnout. So thanks everybody. So John, thanks.
Sure. Hi everybody. Thanks for having me. This is the first time I've been with the group. I intend to come back if you will have me. My name's John Tolva. I'm John Tolva on Twitter if you want to yell at me back channel during this talk. I'm the new president of Positive Energy Practice, which is an engineering firm here in the city. Prior to that, I was the chief technology officer for Mayor Emanuel for 2.5 years. Prior to that, I was with IBM just 9 floors down. This was my view, which I missed. Well, actually, the Trump building destroyed it, but where I was with IBM for 13 years, ended basically leading the data analytics practice for smarter cities. So I'm not an engineer. I'm not an architect. I'm not sure I would call myself even a designer. I'm really a computer science. I'm from the computer science world, but always with an interest in the built environment. And that's gotten more and more exciting as the years go by, as the built environment itself becomes, part of a computing platform. So I'm going to talk a little bit. I'm not necessarily going to talk computer stuff today, but I am going to talk about the way that the city is sort of reconceived, certainly at PEP, but in lots of other places, as a kind of platform in the software sense and in the hardware sense. I start often with this quote: the patterns of data in the streets will affect the way the street feels rather more than street furniture or road signs. Holes in data, public and private, may become more relevant than the pothole in the pavement until you trip over it, at least. This is a guy formerly at Arup. He's now at something called Future Cities in London, named Dan Hill. You might have read some of his stuff. This was a couple years ago when it was like, okay, I sort of get what you mean. When really the concept of a hole in data was more like a cell phone outage, or where you couldn't get a signal. You could see where that analogy makes sense. But as this is like actually pre-smartphones. But today, when you look at someone walking down the street who's on their smartphone, typically they are negotiating 2 spaces at once. The technical term for it I've heard is temporarily negotiated private space. You know these people, right? They're sort of in the moment, but not in the moment. And there are design implications to that, both to the built environment and to the interfaces that they're navigating. So this is what I mean when I talk about the city as a platform. Obviously, it very literally is, and we do a lot of that here at Thornton Town City, at ASGG. But how should that be informed by this sort of new mediating layer, which is really software-based? So I want to start not with software, but with actually with the things we've learned from urbanism and from architecture over the past, say, 50 years. And the first is that throughput is not connectivity. The golden age of the Eisenhower Expressway system, this was not thought to be true. That throughput was the highest form of connectivity. We want massive, so you can see where I'm going here with the analogy to bandwidth. We want the biggest pipes possible, right? To ameliorate, this is, I think, Randolph Street, this sort of classic image of just total mayhem on the streets. Images like this, I think this was Boston. This never took place, but these ideas of like truly disrupting the grid, which is totally redundant and sort of multi-point with these single use point-to-point connections, basically destroying the grids in many cities. This happened in our city as well. This is actually a visualization of the transit of cars in London. When we know from an experiential standpoint that it's really the street level connectivity, the seeing other people on the street, the kind of information flow. So think about a city as an information processing machine for a moment, if you will. People seeing one another, understanding what's going on, the sort of serendipity as a function doesn't happen in that sort of point-to-point conception of throughput. It happens in the multi-point, street level, and that informs software design. What I'm getting at with these things like this, it's easy to confuse the use of a system with the need for a system, is that I believe that the built environment has lessons for the software engineers in the world. At IBM, even at the city, I saw a lot of remaking or reinventing the wheel, right? I mean, there are problems that architects and engineers have figured out, and some figured out like a millennium ago, that we're redesigning in software. Here's an example of this, confusing the use of a system with the need for a system. This is the West Side Highway. I think this is like the 60s in New York City. It was not as egregious as what was proposed, the Cross Bronx Expressway or the Cross New York Expressway, but it went on the west side, and it was an elevated expressway, kind of obliterating neighborhoods in its path. Well, it collapsed. Actually, it collapsed because a dump truck full of gravel was going over it, which is kind of ironic. But there was panic in New York City that the grid itself wouldn't be able to absorb the traffic that was going to then flow off of it. What happened is it seamlessly absorbed it because of the sort of density of interconnections. The point of that slide here is that saying, well, so many people use this, that must be indicative of need. Okay, and think about that from a usability standpoint, right? Designing software to say, well, lots of people, love Windows 8.1 or something like that. No offense, I think that's what you're running there. It must mean that people love it. That is a fallacy of logic, and the urban environment shows us that. Plus, it disallows creative new uses, like the High Line. Obviously, that elevated freight railway was never intended to be the linear park that it is today, but you can't, the primary use of a thing cannot be the reason for its existence. And I think this is a precept that applies in software design. Systems thinking. I think this is the reason for this group, right? The diversity of backgrounds in Chicago computation. We are all involved in some design aspect of systems thinking. But what I found at the city of Chicago is that that's not sufficient for solving problems at an urban scale. You have to actually involve the community. And so much of the work that we do is for developers, is for governments, is not directly for community, that this is kind of a new thing. I mean, the data about the built environment that is available to the public now is so much more than it was 5 years ago, that I think this might actually change, or should change, what we do. Should be a new input. So here's an example. I live in Roscoe Village, which is just east of this. You guys probably have seen this. This is Western Avenue as it crosses Belmont and Clybourne. You guys have probably seen that, right? It is the site of the former most popular or largest amusement park in the United States, closed in 1968, called Riverview Park. And at the time, this was a huge pedestrian area, and it's where the Clybourne Street trolley ended. I mean, it was just like a very vibrant area. And if you've ever been here, it's like the opposite of that. And that is because of the unintended consequences of that elevated street. I mean, some people love it, right? It's like a little bit of freeway in the middle of the city, which is also why there's so many wrecks coming off of it. But what it's done is it's basically made it pedestrian inhospitable, and the built environment that didn't exist in the Riverview era has now responded, basically, by building walls without, further enforcing the sort of unfriendliness of this area. I'll bet you anything that the designers of that elevated roadway did not consider the sort of the follow-on consequences of it. Now, why do I bring this up when talking about systems thinking? It's because we now have enough data coming from the built environment, coming from the people who are in it via Twitter, social media. So it's a mixture of human and sensors, where we can plot one or two removes out from a given intervention. if you do this, this will happen. And that's what's happening in the redesign of that intersection. The bridge itself structurally is at the end of its life and needs to come down. And so the competing proposals now are to rebuild it or to build it at grade. And actually what the city wants to do is build it at grade. And, typical city, or typical alderman in this case, has a town hall meeting where the decision has essentially been made. And data is presented about throughput. I mean, actually they're forecasting because of the lanes narrow, so because you're up above, that you can get more traffic through the intersection at grade. The point is that this is one person, an alderman, telling the constituents, many of whom don't want that to come down because it actually serves as a kind of barrier, a psychological barrier. They don't want people cutting through the neighborhood, right? Which is an argument that I never would have considered, but there's like a very vocal crew that doesn't want that. Where I come at this is from the perspective of open data, right? We're at a point where the public should be equipped with the information that they need, the sort of pedestrian counts, vehicle counts, all of which is in the open data portal at the City of Chicago, to make much more informed arguments rather than just, I don't want cars to cut through my neighborhood. We've got examples in other areas where something like this has happened, and they can look at what's happened. So this goes without saying, an urban system is a complex interconnected set of systems that pretty much describes the internet as well. One of the things that we did at IBM is something called system dynamics. I don't know if you've ever seen a diagram like this. There are positive and negative feedback loops. You try to break a problem down into single positive and single negative feedback loops. This is when you're taught this in school, this is the one you start with, but it actually makes sense because in our world where we are interested in pedestrians crossing roads, you start with a chicken crossing the road. Obviously, the more eggs there are, the more chickens you get. That is a positive feedback loop. The more road crossings there are over time, the fewer chickens you get. Okay, so scale that up. Add in other things like farmer hunger, the egg laying rate, the number of, the hatch rate, and these sorts of things. Now think about that in terms of the intervention that is a building, or maybe even simpler, the intervention that is a bridge. We're going to take the Wells Street Bridge out like they did, and replace it. You can imagine, it looks like a bowl of spaghetti, but something that charts all the different positive and negative feedback loops. And one of the reasons you do that is to try to see, where are the super nodes? Where is the point of intervention, whether it's a bad example, where you have the most sort of arrows coming off of it to say, what is that lever that we can throw that will have the greatest impact? And it also shows you unintended consequences. So this is the Rose Kennedy Parkway, which is basically on top of what was known as the Big Dig. I think it was the I-10 freeway that they buried in Boston. And, think what you will about the idea of burying a freeway, but the problem was, has anybody been walking through this area? It's like a big linear park in the middle of Boston. It's not great. And the reason, the effect of burying the freeway didn't have the outcome that the planners wanted is because the environment around that I-10 for 60 years responded to it in a way by sort of turning away, by basically ignoring it, that just putting greenery in the middle doesn't alleviate that. Ask me again in 60 years, maybe this itself will have revitalized the area, but it looks a hell of a lot different than this, which is another street in Boston, right? And when you're plotting the and we know these things. Some of this comes from data. Some of these are just best practices in urbanism. These can be plotted out in a series of sort of flows that allow us to make predictions, or at least probabilities that something will come to pass. And this is where the computation aspect comes in, right? Because sure, you can do a couple of those chicken and egg things in your head, but very quickly that gets to be at a level where you need computation to help. So let me just talk a little bit about the raw material that a lot of us work on. It's the data that's coming from a building or coming from a city. From the City of Chicago's perspective, the reasons we are the leader in open data as a city has a couple of reasons. The first is transparency, which is really maybe not that important to us. It's important to journalists. It's important for the sort of political credibility that it buys folks, and it's really not all that interesting to me. But it does lead to things like the top data sets that everybody loves to look at. Some of them make sense. Some of them don't, like current employee salaries. But a lot of these actually do have very good information, and it allows you to do things like, this is where all the bike racks are in Chicago. This was even pre-Divvy. It allows you to do things like this, which was very useful this winter, which is where the snowplows are in real time, which strangely, at least in the first year and a half working at the city, was the most popular thing on the website, which is bizarre when you think that the train tracker and bus tracker are there too, and they're far more useful than plow. You can't hail a plow, to take you somewhere. The cynical read on that is that people were interested in seeing, confirming their ideas that plows went to certain places first. Which they do. They go to bridge decks and arterials and things like that. So transparency does have a place. People want to see the mechanism. How does a city actually work? And as we build these, we're working, Anthony and I and some others in the room are working on a project in Kazakhstan at an urban scale that is, fully outfitted with smart grid and network sensors and things like that. And obviously that's got efficiencies in operation. That's why you do it, to save cost. But it also has efficiencies in this realm, which is allowing the public to peer in to how this mechanism that is a city works. There's value to that. There's a hell of a lot more value in accountability, though. Open data, publishing the city's vital signs. This is something the private sector has known for years, right? It's sort of sad that this is a novel thing in the public sector, but measuring how it's doing. How are we doing providing this service? How are we doing, in whatever sort of infrastructure system that you like? So, the various metrics for calls and service deliveries and licenses and permits and things like this. This is from a couple years ago. I'd love to see this. It's online. This is pothole repairs. I'm sure it's an ugly, ugly graph from this winter. But where it gets really interesting, and I think much more germane for this group, is that these vital signs allow us new opportunities in analytics, right? To look for patterns that the human capacity for mathematics just can't do without a sort of data-driven decision-making process. And the truth is, most of the data that we care about is spatial, has some sort of spatial quality, right? So that's real-time data where things are in a building or in a city. It's what we call scheduled interactions. That's really future data, what's coming up, that allows you to be smarter about about your resources. But the big one is historical data, and I think this is what's going to change. Now, you might have seen at the beginning of this year, the city of Chicago passed an ordinance requiring buildings at a sort of tiered rate starting in June to release their energy benchmark numbers. Starts with 250,000 square foot buildings in June, and eventually it'll be all of them. Put that in this category of data that then I should think is a raw material for everybody in this room, right? That will allow us to sort of prioritize retrofits, to look in a very quantified way at what the sort of carbon landscape is of the city of Chicago. This is good for us. It allows us to do things called operational awareness. Now, you guys may work with building engineers, people whose job it is to run a building. What I'm going to show you here is an urban scale version of that, of knowing what's going on at any given time. So in, 2012, when the NATO conference here, you guys probably all got out of town, but the mayor wanted a way to look at sort of an arbitrary area in the city and know what we already knew, but in one place. So where are the buses? You might remember there were the folks who were protesting. It was very, very hot during the NATO convention. And so we had empty buses basically following them with air conditioning going on. We wanted to know where those buses were at all times. We wanted to know where the sort of building violations and permits had been given. The thing is, in a building, as in a city, all that data is in different databases, and yet it's all spatial. And so we built this system to actually pull it all together. If you guys have ever used Foursquare, it's like Twitter for places. They have a backend. They use a database called MongoDB, and they were the ones that actually gave us this idea. Because if you think about what Foursquare is, it's a lot of spatial data very quickly, in great volume. That's what this is. It just happens to be things like where the buses are, or in this case, buses mapped to what was this here? This is a 311 call, or here's all the 311 calls and where those buses are. And you can change things like the area that you're looking at. This here is open and completed 311 calls. Here's by category. But what really starts to get interesting is here. These are 311 reports, so pothole, tree down, whatever, mapped with tweets. Now, that's obviously not the city's data, but it is public. And why do we do that? We do it because those tweets actually are kind of a proxy for data we don't have. oftentimes it contains more information, like there's a sofa in a sinkhole. That wasn't part of the 311 call. Or no one actually called anything in. It's just a bunch of people tweeting about somebody getting ill at a restaurant, which happens quite a lot, as a matter of fact, right? Where you go with this, and think about it in your own sort of line of work, is what are those sets of data that were never intended to tell us X, but do tell us X, right? One example of this is I've got a HVAC engineer who, the holy grail in a room is, from an HVAC perspective, is to know how many people are in that room. Not who they are, but that they are, right? Because that changes the where the vapor wall is. It changes how you climatize that. We just don't know these things. But there are things that could tell you that, like the IP leases from a wireless router, can be triangulated to tell you that. We're not there yet. I will tell you. But what are those sets of data that can inform design? Like here. That it let us do sort of proactive service requests without anyone ever calling 311. All right, so for the nerds in the room, this is what we built all of that on, and it's open source. If you go to github.com/Chicago, you can see all this for Windy Grid. The other thing that we did is actually using Twitter itself to mine for patterns, to geolocate it to Chicago. This is the CTA, but we actually did implement a foodborne illness scan. So as it happens, people love tweeting about getting ill or their friends love tweeting about others getting ill at restaurants. And the hardest part about doing this is basically disambiguating all the slang and homonyms and synonyms that are used in doing that. And what you do is you basically set a threshold, not to send someone out to inspect the restaurant, but to alert the public health department to say, look, there is a critical mass of conversation happening about this thing. And that is like an ambient service request. Nobody ever actually called 311. But the best reason to do this is that open data, the data from the built environment, builds new businesses. I'll bet you, and if it doesn't build new businesses, it helps existing businesses. This energy benchmarking ordinance, for instance, will be a boon to our industry somehow. I don't know that we know how, but having it be just a standard operating procedure that we know what that building is doing to the environment is good for us. It starts at the volunteer level. It starts at things like hackathons. This is Google hosting one of our hackathons where you've got people sort of coming together and saying, what's the low-hanging fruit here? I think we're past the low-hanging fruit phase, which was like transit apps. And there's a competition that we ran a couple years ago called Apps for Metro Chicago. Like, what are the little things in the city that we can nip off? You should know about this. If you park your car on the street, you just put your address in, and then the night before the street is to be swept, it sends you a text message or an email saying move your car, right? And that's the idea, is that we went through this phase of like e-business, and remember that, the e stuff, like e-government and e-business, where it's like, now you can pay your parking ticket online. That's not that much more pleasant than just paying the parking ticket. That doesn't make me feel any better. I still got a parking ticket. The point of this was to use data actually to help you not get it in the first place. This was an example of Little Village, a neighborhood here in Chicago, has one of the lowest square acreage of green space in the city. And they're getting a new park. And because it's in such high demand, the community was very vocal about being involved in much more than just a town hall with the alderman. They wanted to be involved at sort of every step of the way with the developer and with the park district. This is the kind of amenities that we see here. And so a group of developers got together and built in Spanish, largely Spanish-speaking area, an app called Mi Mapa that allows sort of real-time voting, photos to be sent, and it's an input to the developer. I don't know that there are necessarily engineers involved here, but certainly landscape architects, that just doesn't exist in the typical model of a kind of public hearing. I'll skip through some of these here. This is a business that's opened up on top of it. This was resurrected from the dead just last year. EveryBlock, I don't know if you've heard of this, is one of the very first sort of block level aggregators of data. But I'll scoot along here to really the title of this talk. And by the way, that wasn't all prologue. I'm about halfway done here. What do I really mean by the city as a platform? Well, when you leave here, walk down the sidewalk and for a moment be a true nerd and think about the built things in the environment, certainly in the public way, not as things, but as network endpoints, and see how many you count. That is, what of these things is on the internet? So you've got those signs on the L platforms. Love them or hate them, primarily hate them. The parking meters, those are computers that are on the internet. Even those compacting big belly solar trash cans, that's how the city knows that they're full. But the most interesting of all, I think, is Divvy, right? Every one of those 6,000 bikes when they hit the dock is on the internet. And it's sending back it's sending back route data. Which, if you think about it, is incredibly useful to the transportation department for route planning, for wayfinding, for determining where new bike lanes go. That's just a set of data that didn't exist before. And just last night, that data is public too. There was a challenge actually to come up with the best visualization of that data. But think about that even further. It's not just that the city is a platform, but that piece of city infrastructure is a platform. The city's going to outfit a subset of those bikes with environmental sensors, air quality sensors, that will generate a footprint of data that no amount of stationary sensors could ever generate, right? And when you're trying to plan the interventions for like the urban heat island effect, you need like sub-block level climate data that you're just never going to be able to pay for that many stationary sensors. So thinking about infrastructure in a way that reuses it is thinking about the Internet of Things, if you've heard that term. So if you take out the video, the Netflix and the YouTube basically, that goes over the internet, I don't doubt this, that Gartner says that 20% of the internet is machines talking to one another, not people talking to machines or people talking to people, which is the Internet of Things. Now, that's kind of a geeky way to phrase it, but if you think about it, the city is where that's happening. You know, the density of people, the density of sensors, and all the overlapping interconnections, we are, you know, the Internet of Things, networked devices. And I pose to you that it is our profession, the design profession writ large, not the IT profession, that should be designing that Internet of Things. Just like we design the buildings and the structures and the HVAC and the plumbing, that the way that environment talks to one another should be in our wheelhouse. The internet is a very physical thing. So this is just right over there, Wacker and Franklin. You can't read that, and it doesn't really matter, but if anybody's interested, I can send this. This is just like a snapshot of all the sensors that are at that intersection. Some of them are private, some of them are run by the Coast Guard in the river, some of them are from the city. What do you got? You've got water sensors, fire sensors, lighting sensors, smoke detectors, triangulation systems. So it's there, but it back to that photo from the 19th century, if you visualized that network, if it were visible, it would look like this. It's just totally disconnected, inefficient, underutilized. This is an opportunity, I think, for our profession. Now, you know, the question I ask is, there's information architecture, as it's called, which really pisses off architects, by the way, but it is an actual discipline. In the physical world all the time, you know, those scrawls on the ground mean something to somebody. But how do we think about designing a city that's as influenced by its information architecture as by its physical architecture? There's the easy stuff, right? You've probably seen this. I think this is in Helsinki. You know, providing data, hyper-local data, that is actually meaningless one block over or 10 minutes in the future. Largely that's wayfinding, it can be environmental, those sorts of things. But I actually go back to a really low-tech example. I don't know if you've ever seen this, but if you don't have a smartphone, you can still get bus information with just a feature phone. Each of those signs, each bus stop has a unique SMS short code. You can text it. And the reason I love that is because it is, even though it's going over the cell network, it is like you're interrogating the sign itself, right? You're having like a direct interaction with a public object. In this case, network public object. What if more things in the environment were like that? Where you could query it or interrogate it in some way that was useful to you as you move through the city. Now, the inverse of that is how is the actual physical environment shaped by network technologies. This is a laying of a water main, or actually a sewer main, that we said, you know, why don't we just run fiber through the sewer? Who cares? You know, the data doesn't get dirty and it's totally protected. It'll never be cut. Once you start once you admit that the internet is a physical thing and that there are physical implications of it, you start seeing where the cell phone towers are and the repeaters are and the fiber manholes in I mean, you guys probably know this, but people think that the internet like rains down from heaven or something like this, just this, totally disembodied. But there are real implications to the kinds of things we design, and they change the way that the spaces are used. This is free wireless, I don't even know this, in Millennium Park. That's made to sort of, I don't know if you can see that, made to like totally blend into the background, but it changes the way that park is used. For one reason, for the sort of electrical engineers in the room, that lattice over the Great Lawn is almost a perfect Faraday cage, which means that those Wi-Fi signals bounce around and get amplified. You get incredible signal in there, which is obviously not why that cage was designed. But it does change the way that people use spaces, going back to that sort of temporarily mediated private space. Now, this was an April Fool's joke from a couple years ago in Philadelphia, which fooled me and a lot of other people, maybe because I wanted to believe it, where they striped their sidewalks with texting and non-texting lanes, which, it's like, okay, that would not really fly. But then you're like, maybe that's kind of a good idea. But it does make you think, why haven't, or maybe we have, maybe there are urban designers out there that are thinking about the effects of invisible technologies on how we use a space, how we make a place, and how does that translate into the real world. So we can call it something else, but a networked urbanism, a networked urban design practice, I think, has these qualities, or these are why you strive to do it. You've probably read Kevin Lynch's work, where he talks about the legibility of a city, the ability to read a city. I think that's, as apt as ever when we talk about network technologies, making it more intelligible. My children, and this has good and bad consequences, but my children will almost certainly never know an experience of the city that's not mediated by some sort of digital overlay, whether it's a phone or a glass or a headset or something, right? So that's, again, that cuts both ways. But if we admit that that's probably the truth, then why shouldn't we be the ones that participate in the design of that? This is more from a government perspective, but when you move digital interaction away from a computer and into physical spaces, whether it's a cell phone or on the wall or literally sensing you, it reduces, the time you wait in a line or online. And this last point, which is kind of connected to that, is when the skills that are needed, the digital literacy that is needed, is part of a routine that you already know, rather than the sort of 31% of Chicago doesn't have a broadband connection. They wouldn't know what to do if they sat down in front of a computer. But I bet you those folks know how to navigate a city. Right, when you start to put the digital interaction and mesh it with physical, you're capitalizing on knowledge that's already there. And I've talked about some of these others with the sort of economic development consequences of it. So just very quickly, if you haven't heard of where I work, Positive Energy Practice, it's 4 years old. We are, I suppose categorically, we are a mechanical, electrical, and water systems engineering firm. That focuses on a couple things. I mean, the basis of the founding of it, it was founded by the partners of Smithgill Architecture, who we share a space with. We are a separate company. We do about half of our work with Smithgill and half with other firms and buildings directly doing retrofits. But I was just talking earlier tonight with the gentleman over there about, the big role that education plays in if you are in the sustainable or sort of clean tech work. So though energy and the ecologies really is the sort of urban scale work is our focus, education is a big part of it too. So, I mean, I'd love to give talks like this, not with you guys, because this is sort of like, in some ways, preaching to the choir, but, with our clients, who maybe don't see things this way. But if the demographic trends for city dwelling are to be believed, there's almost a moral argument for making our cities smarter, making them more sustainable, simply because of the densities that are projected that we're going to be living at. Obviously, economics underpins all of this, and that's why I didn't show you much of computer modeling, but much of what we do at PEP is like Windy Grid and like some of the things we did at the city, which is taking data and helping us see what the economic or what any other sort of quantifiable implication is of a design change. you know what, I mean, we do this to some degree in architecture all the time, right? You turn a building like this, how does that, influence the thermal envelope and things like that? But we now have so much more data than we did about the built environment that we can ask ourselves other questions, like what probability is there that this will stimulate economic development? And you don't do that by just guessing. You do that by looking at past data, right? And you've got about 10 years of it now. So here are the areas that we focus in. This probably won't be a surprise to anybody. But one of the things that we think is a differentiator, or we would like it to be, is our focus on software tools. Computation not as a sort of separate engineering discipline, but as a platform for our engineers. So many of the tools, we've got. As I said, I'm the only sort of non-engineer at PEP. That's not actually true. We have a small computation group, small and growing, and we're hiring. That primarily looks at like what would make our engineers and our clients better understand the implications of decisions, which flows directly from the sort of data-driven decision-making ethos. So just some of the work that we're doing. Our biggest project right now is in the capital of Kazakhstan. It's called Astana. It's a 20-year-old city in a resource-rich country that they are building this basically 1 square mile adjacency to the capital that they intend to be positive energy, which would be the first project we've worked on where we live up to our name, that generates more energy than it consumes. Obviously, there's all kinds of opportunities for thinking about digital models prior to building anything, prior even to designing everything, as being the sort of what if scenario tool, which you can see from the rest of the presentation is where we're headed. So anybody ever seen this painting? It's called the Lackawanna Valley. It's from 1855. Anybody know this painting? It wasn't very popular at the time. I don't think any of us were around then, but the style of painting in the United States in the early 19th century was landscapes. And this was inherited from the sort of pastoral art of England, right? Is that, and this notion of the New World as being this unblemished Eden. It was like, especially in the West, right? It was this garden. It was the opposite of the like Dickensian factory. It was the opposite of Victorian England. And then the railroad came in, and you started to see these paintings where, count the number of smokestacks in that. You've got like 4 or 5 in there, right? What was referred to as the machine in the garden, right? That actually it wasn't the pastoral that was the defining image of of the United States. Although Chicago's interesting in that history too, but it is the intrusion of this sort of fire belching, loud as hell machine into the serenity of the West, and that actually came to be the sort of pop. This was the birth of American studies. Like how are we different than the rest of the world? And eventually those two came to live in relative harmony. It was no longer, shortly after this, it was no big deal. It was actually reassuring to a town. A town wanted to have the railway come through, right? That was a sign of sort of economic prosperity. And I think about this painting as I talk to my sort of younger engineers, to say, look, you don't have to want to save the world. What you have to admit is that the systems that we design are part of a larger landscape that is a natural landscape, and it's also an artificial. We can design both. And all you have to ask yourself when you're doing that, and the reason we're putting these computational tools into place, is to help us ask these questions before we dig up the ground or do anything, is does it contribute to the health of that landscape or detract from it? And again, I don't just mean the natural landscape. I mean, when you go into retrofit a building, that is an existing landscape, if you want to call it that. And is what we're doing contributing to the health or detracting from it? All I ask my engineers to ask themselves is, how will what I make, what I design, perform in harmony with the environment around it? That really is kind of the and reach a harmony that this concept of America did. I think we're somewhat unique in the, not PEP, but America in this having always to deal with the natural world and technological innovation and how they work together. So I'll leave you, and maybe we can have a bit of a conversation. This is one of my favorite authors, William Gibson. He's a sci-fi author. When the first iPad came out, he said, we won't really know what the iPad's about until we see what the street decides to do with it. Which is true, but that scares software people, right? When you design software, you've got a list of like criteria, then you test against it, and if it doesn't work, you go back and but by the way, prior to putting it in anybody's hands, if it doesn't do it, you remake it. What makes cities awesome, the reason people really love or don't love a city, is the ability to use it in a way that it wasn't intended, to carve a path that wasn't there, to use it as a platform, in the truest sense. That's the opposite of software development. And I think if we're really going to make these two mesh, we have to actually let go of a little bit of control, right? And I'm not talking about parametric models or anything like that. I'm talking about the actual things that are the mediators between the real world and the digital world. We need some flexibility in there to do interesting new things that the designer never thought of. In a way, open data is that. We put data out there, and we don't know what people are going to do with it, but it's probably going to be interesting. So that's where I'll end, and I will thank you for your time, and maybe we can have a little bit of a conversation. Yep.
Thank you.
Yep.
With all the Internet of Things, I'm less worried about privacy than just security. The idea of nasty hackers deciding for good or just for fun, I'm going to do stuff. All you have is information dump. You're less likely. But as we know, especially as architects and designers, we want to have interactive systems.
Yeah.
And
No.
what are your thoughts as to how that's going to flesh out?
If you look at the early smarter cities commercials from like Siemens and Cisco and IBM, they are these like perfectly functioning clockwork utopia, and you're like, where are the people? It is like this sci-fi world. They never got the fact that these systems, first of all, we only build these systems to work because they serve people, and that they break when people are in them, right? Engineers and architects and designers start from that precept, right? That we know what happens when you put wetware into the system, when you put humans into the system. IT folks don't necessarily think that. I mean, the usability world does. I think we cannot let big IT design be the sole designers of the things that control the Internet of Things. I think that's very dangerous. It's dangerous in a post-NSA world. It's physical hardware has been hacked. Downstate Illinois was the site of the first hacking of, I think it was like a water pump or something that was made to basically run itself out. The United States government has all but admitted to destroying a centrifuge in Iran by way of software virus. So the physical world can be hacked. One of the scenarios that we ran during the run up to NATO was, and this would have affected you guys, is could someone lock all the bridges up in the up position remotely? The answer is no. Right, but in an Internet of Things, in that world, you could imagine where that is the case. It's all manually done now, but so there are implications. I think the engineering, the disciplines that have been doing this for hundreds of years, and know where not weak points, but where the points of greatest impact with humans have to be involved in that. So,
well, I guess part of the reason I pose the question is, as you just said, the great thing about the city is using it as it wasn't intended or thought about. And then you run into that same situation. Oh, I've got the data and I've got the access, and it's going to be used in ways you didn't intend.
But there's a difference though between being blind to the opportunities for hacking. Hacking is the wrong word actually. Blind to the use in a deliberately destructive or criminal way.
Call it
An
an attack.
attack, and uses that we just couldn't have imagined. What that Divi data visualization from last night showed us, something that I'd never seen, is that something like 30% of Divi trips are taken in groups, which is not because Divi's not tourists, it's very few. It's a Chicagoans who use this, and I think that will probably have an impact on the design of the lanes, right? If people are traveling in groups, and we just didn't know that before. And yet the system was flexible enough to permit a use that we didn't intend. So this is the great balance, because if you're too strict and lock it down, no hacking of any kind, it probably will feel a little restrictive to everyday users and not as pleasurable.
Is it the larger use of the data? You spoke about open data.
Mm-hmm.
It's not so much the hack of the data, it's the misuse of the data behind closed doors. Yes, I rode Divi from my apartment to the office today. They have my credit card, therefore they know who I am.
Yeah.
They know what time I went through each light. So the 3 red lights I ran, they know that. Someone can decide, we'll use that data to send you a ticket because we know that data remotely.
Yeah.
As long as that's sort of behind the closed door, that's, I think that ties to the whole NSA thing, the larger misuse of data.
For
the
sure.
Unintended consequences that becomes Big Brother. And that's the fear of it.
Right. That's why you need to have policymakers keep pace with the technologists, which is a very hard thing. I will say that there's misuse of data in all areas. I mean, the stuff that is known about you simply from you using your credit card is terrifying. It has nothing to do with Divi, right? Actually, that really was my job in the city. I didn't keep the servers running. I was not the CIO. I was basically trying to translate the policy implications of technological decisions. And I think you're starting to see that as a very valuable role, not just in cities, cross-disciplinary folks. I'm not saying I did a great job of it, but like people who speak multiple languages. And one of the reasons that I look to design rather than hardcore IT is that you are all you have to translate between disciplines. That's what design is. And the implication for privacy in your example is someone who speaks the policy world and speaks the data world. There's no technological solution to your problem. It is you know what I mean?
It's the issue of open data. Fundamentally, as long as you as a community, as a group, have a conversation and agree and say, yes, we are going to do this, or no, we're not going to do this, as opposed to allowing a set of entities to do it without your say. The whole idea that you have the community involvement, I think, is the key takeaway that I got from this.
Yeah.
Yes, we collect all of this data. Most of us don't know how it's used. If we all did know how it was used, would we change our habits? Would we ask things to be done differently?
Well, I think your data is being used at Amazon to try to sell you more shit. It's being used at Facebook to God knows what they're going to do with the VR goggles that they just bought. I think you have to then just be much more vigilant about the transparency. Demand to know who sees that data. The city of Chicago does not see that data. Divi is a separate company. Could the city demand it? Maybe. Could the federal government? Maybe. One of the things that is lacking in the transparency world is transparency. I think is what you're talking about is transparency of process, not just transparency of data, but like what's being done with that. That's a harder thing to make transparent. What do you want? Put a closed circuit camera in a I'm not saying it's impossible, but it is a tougher thing to be solved.
Another point that maybe it kind of follows up on that is a discussion that we were having about are architects and designers the best equipped to engage this conversation. So the question is not necessarily how other companies are utilizing this data or exploiting that data. How are architects and designers using and exploiting that data? And do you think that with your interactions with the city or now as consulting to architecture firms, is the design profession engaging in a way that is meaningful or useful, or designers didn't come up with the Divi bike system or the open data portal, or
I think engineers have always been data driven in very specific niches, right? Like the mechanical engineers, run performance simulations. That is data driven decision making. But it's usually constrained to a single system and not the implication. I just moved my core like this. What does that do to the electrical, like in real time? I actually don't think we have the tools yet. It struck me that in managing certain of the projects in the city that we had more sophisticated tools than the people who were working for us, the architects and the urban planners, did. And that struck me as fundamentally wrong, right? That the private sector should be out in front in some ways. This is the private sector, me speaking. But it isn't to say that there aren't very powerful tools already in the employ of architects and designers. I think the coming of CAD and GIS and Autodesk and Revit and all that stuff was such a game changer for this industry that it's possible that it's blinded us, I think, to the non-3D aspect of modeling. Mostly what I'm talking about here is modeling things through data, which is not as viscerally compelling as 3D modeling. But I think you can have both. I think this is a market opportunity, right? The software tools that kind of bridge that gap between three-dimensional design. And then, now you may be asking yourself, City of Chicago has a lot of data, but most of my clients are not in the City of Chicago, right? They're in the Far East or the Middle East or something like that. And so what you do is take, there are data sets in those cities that are useful to us, but what you're looking for are analogies, and they become less precise. Like, this was done in Tokyo for where we do have the data. This is a parcel or a district in Tokyo that has, X many characteristics that the new one in Chengdu does, and you do a simulation that way. No, I think the tools aren't there, and I think that's exciting, actually. Yeah.
So John, much of your speech resonated a book that I read by Anthony Townsend.
Yeah.
Maybe you are aware of.
Smart cities?
Yes.
Yeah.
The civic hackers.
Yeah.
And my question is, in Chicago we are seeing voluntary donation of open data, but since you've been in the city and worked with the mayor, do you know which data they select, and how do they select what to post, what to include in the center of the open data portal?
Yeah. It's not so much what's supposed, it's in what order. Because, first of all, it's required by law. It was put into law. So everything that is not personally identifying information, PII, has to go out. That doesn't apply to the city, the sister agencies. So the parks have their own policy and things like that. But what you're really asking is, what is how do you prioritize it? For the first 6 months or so, we actually was just shoving it out. If we had it, we put it out. Primarily because the previous CIO had done all the work, but he never got permission to release it. So there was stuff ready to go, and we just got that out. And then we started to be more sort of tactical about it when it aligned with sort of a policy announcement. But now, you guys know what GitHub is? It's a code repository. Now we fork. Philadelphia was the first city to do it, and we followed their lead. We fork our data portal into GitHub, which allows people to actually modify, correct, and suggest in a much more powerful way than just an email saying, "I'd love to see the number of helicopters in Chicago," or something like that. And so now it really is a more sort of community-driven thing. And there's a group that I see a lot of overlap here. Happening right now is another meetup that we should get together with sometime. It's called OpenGov. And it's a bunch of sort of civic developers, civic hackers. There's a ton of overlap with this group here. That community is hundreds of people strong, and is one of the driving forces in how we release data now. Because they're the ones that make it intelligible to the rest of the world. I mean, that's the thing, and this is another market opportunity. The tools, all that data is maybe useful to us, but like your average community leader or business owner or pastor at a important church in the neighborhood, they don't know how to make sense of that. So you need that sort of app or web interface. And the folks who do that, often push us and say, or I'll give you another example. One of the reasons for putting out all of the city building energy data is because we wanted that to coincide with the ordinance requiring everybody else to do it, right? So this is what this type of stuff looks like. We were able to put our own energy data out. So sometimes it's policy announcements, but it's largely driven by the community now.
In the ordinance for the energy, there is a group for a PE or a CEM or certified energy manager to check the data, or a licensed architect.
I know.
For the quality
It's
of data.
the chicken.
Now,
Yeah.
For anything else that's released, that loop is not there, right? So is it basically to the grabber to filter what's trash and what's useful, like you did in Twitter for the people vomiting after going to a restaurant?
There are lots of checks on the systems. I mean, I think that system with the energy data could be made a little tighter. I mean, a little bit of that could be the fox guarding the hen house, right? You've got a P or something who's got a vested interest or like a building engineer vetting his own data. One of the reasons that it actually takes a long time to release data isn't because it's hard to push data out. It's hard to put those feedback loops in to sort of constantly be vetting what's coming out. It's very few data sets go out once and then they're done. So you've got, a lot of the city data is from the city government, and so you've got experts like in the water treatment plant that vet the flow rates and those sorts of things. But no, that's part of it as well. I mean, the energy ordinance was very contentious. I don't know if there's anybody from BOMA here, but building owners They don't love it. And so, that's where open data meets politics. But it was a priority, so we got it.
Can you talk about the education you see required for the people that are doing the facilities management, not the ones that are installing the systems? And
No, I know what you mean. Yeah. That's tough. Like building engineers, basically.
And the generations in Chicago that are sort of way past that and probably unionized.
They are unionized. They are, well, most of the building engineers I know are, and don't have real incentive to change their control system or to give up their data or to say, or even to care that the building next door is much more efficient. The property management company does, though. I think you have to go up a level. Now, I think eventually you will get a generation of engineers in those buildings that just sort of naturally thinks about informing their decisions with data. But the CBREs and the JLLs of the world, they are highly, there's lots of incentives for them to, and you can make a bigger impact too because, they manage them across a portfolio of buildings. They're the ones that you go give the demo to. I mean, the decision maker is not the building engineer. It's not even really the manager of the building. It's
at a certain point you have to educate that next generation, and they're not the people that are going to be doing those jobs later on aren't necessarily going to the same universities that we all went to.
Yeah. No, it's true. I think it's why we need the tools that Anthony was asking about, because you can give these talks till you're blue in the face, but if philosophy is nothing compared to like an actual visual tool that shows you making trade-offs in the operation of your building and what the consequences are of that. And I think like anything, the academia will catch up. I mean, architectural engineering as a discipline didn't even exist 20 years ago, and now a lot of the folks that we see have that new degree. And I didn't go to engineering school, but there's no lack of sort of openness to data in these schools. Our engineers, I don't know if you remember, I went to grad school with this guy over here. In the early days, it was only the engineers could get web accounts because they were. It was thought that like they're the ones who are on the cutting edge of web tech. So, I mean, I'm not pessimistic. There will be a lag. There will be a lag with that generation. Thanks, guys.